All right, perfect. So let's begin. First of all, thank you so much, everyone, for taking the time out and coming for this webinar. As you might already know, this webinar is on magnesium alloys and how it will make an impact on the lightweighting of design, mechanical design in the upcoming few years in India, we believe. So let's get to it. So just basic hygiene, we wanted to set a few webinar rules. As you might have already noticed that the mic has been muted. So all your questions can go directly into the chat box. And as the session progresses, whenever you have a question, just mention it in the chat box. My team member will take a note of it and give it to me at the end. If there's any question that I feel is relevant for immediately, I'll answer it on a real-time basis, or else I'll take it at the end. Right? Try to make sure that all your questions are generic so that others can also benefit from the quest Q&A. And if there's any kind of industry specific questions, we'll take that at the end, or we can schedule a call back or answer those questions by email to you specifically, right? Try and stay muted the whole time, and if there is any kind of technical issues, please be patient. I have a backup laptop just in case. I have a backup internet just in case. So if you're having any issues with the sound or with the video, please log out and log in. It's open, so you can do that multiple times over the course of the webinar if needed. So just to let you know what we will be covering during the course of this webinar. So we'll talk about why lightweighting, how to lightweight, the materials that are in play currently in India for lightweighting. We'll go a little bit deeper into magnesium, and I'll talk about the major benefits, the major myths that I see when I'm talking to design engineers and R&D teams every day. We'll go into the manufacturing possibilities, and at the end, I also have a giveaway for you guys if you stay till the end, and we'll follow that up with a Q&A, right? So just to tell you a little bit about myself, my name is Anish Raj. I am the director of Exclusive Magnesium. I'm a metallurgist by education, and I did my specialization in magnesium itself during my engineering. And for the past 6 years specifically, I've been working in magnesium space. And this is a second generation family run business. To tell you a little more about the business, it was set up in 1994. It was the first private sector magnesium foundry in India. We exclusively do only magnesium components since our establishment. We don't do any kind of other non-ferrous unless required for the mechanical sub-assemblies that we work with. We are certified for our quality for airworthiness by DGAQA and AS 9100 certification we have. And apart from that, ISO 9001, 14001, 45001 is also something that we've certified for. Just a milestone from last year that we are very proud of is that last year we did a single finished part which weighed about 1.7 tons. It was a single melt sand casting. It's the largest sand casting ever done in India, and we believe that this is the largest single casting done in magnesium globally. We also applied for the Guinness Book. Let's see what happens. So as I mentioned, we are the second generation family run business, and we've been supplying to aerospace and defense for a very, very long time. Recently, about 5-6 years ago, we started into private sector, and we've seen a tremendous growth in the private sector as well. As a company, what we are trying to do is we are trying to capitalize on the power of material science to help innovators build energy efficient machines of the future. And we believe that can happen through lightweight materials, right? And the material that we're betting on is magnesium alloys, metal matrix composites. So that's what we are into, and that's what we believe we can create a dent for. Just some of our clientele. We work with some of the biggest brands globally, from Mercedes to Ducati, or even drone startups in India. We work with them all. Anybody who's interested in lightweighting and is interested in magnesium, we are interested to talk to you. So no matter how big your project, how small your project, we work with all of them. Over the past 29 years, we've worked with 6 different countries. We have exported to the US, UK, Germany, Austria, Sweden, Israel, and India is our biggest market right now. And Yeah, we worked with over 300 brands, 300 companies over the course of our time. Majority of our services in India currently are through aerospace, defense, industrial equipment, automotive, drones, consumer electronics as well. Academia is a big part of which is exploring magnesium actively in India. We've seen a huge boom of research happening for magnesium currently. In terms of our capabilities, we do all kinds of castings. So sand casting, high pressure die casting, gravity casting, centrifugal castings, also machined components, extrusions and forgings. So anything you want to make in magnesium, if we don't have an existing process, we will develop it and make sure that we make it, right? So we don't want to give um, any excuses of why it cannot be made in magnesium. We'll develop it and make sure that we provide you the components that you need. All right, so let's get into the main part of the webinar. So we'll start with why lightweighting. A lot of engineers that I've talked to are not even sure why they should focus so aggressively on lightweighting. So I'll tell you a few key reasons that we've observed over our time that has made a huge impact to our clients and how they are thinking about their products, right? So the first key reason is obviously to improve performance and efficiency. To give you an example, electric vehicles currently in India, there's a huge range anxiety that's linked with consumer behavior, consumer concerns. So, charge, how much range can my electric vehicle give me in a single charge? Do I have to worry about where will I charge during the course of my journey? How long will it take to charge? So they plan their journey and they're very anxious about how many kilometers they can run before they have to recharge, right? So in such kind of environment, and this is not exclusively for electric vehicles, but in across industries. So for a drone startup, you're looking at higher flight time. For a robotics company, you're looking for longer run times without so every industry has their own performance and efficiency standards, and I feel like lightweighting is the key critical place where this can be impacted. The second is obviously a superior product. Now when you're looking at with lightweighting as a primary uh, superiority feature, you can look at the laptop industry currently itself. You can look at that the consumer behavior right now, they're looking at anywhere between 1.5 kilos to 2 kg weight of the laptop with the highest functionality. So a lot of laptop companies over the years I've seen that they're looking at high functionality but also lightweight, which makes it the superior product for the whole industry. So building a superior product through lightweighting can also make a huge impact. I'll cover examples for each one of these as over the next few slides. Expanding functionality. So to give you an example of how functionality can be improved, say in a car, when you're looking for larger cabin sizes of the vehicle, but you don't want to increase weight, right? So you want to give an additional functionality of space, but not increase the weight of the component. That's where lightweighting plays a lot of roles. There's a lot of examples of how functionality can be improved with just lightweighting, improving ergonomics of a single chair, or there's a lot of examples related to that as well. The fourth major reason for our customers and that we see is reducing cost. Now, costs come in a lot of ways. It could be manufacturing costs. So recently, we worked with a cricket helmet manufacturer who was transitioning their design from steel and titanium to magnesium. That made it lighter, but also moving from a welding structure to a die casting, it significantly reduced their price as well, right? So lightweighting can also help you reduce your weight and the price. So that's one example. Another example is industrial equipment, where the amount of energy used by the machinery matters to the customer, right? Another example is where the weight of your product directly is related to the cost of shipping and packaging, right? So lightweighting can benefit a product in several ways and can reduce costs in multiple ways. The fifth reason is the creating like a blue ocean product. So in absolutely saturated markets, I've seen multiple times where you take the same old product, you create a lightweighting feature, and you completely recharge the industry. A couple of examples I'll share in the future slides, but one of those is the badminton and tennis racket industry, which was completely disrupted with carbon fiber and magnesium alloy frames. So it became the rackets became significantly lighter and significantly durable, right? More stronger. And it's a huge industry today. I'll talk about that in the next slide. The last one is sustainability. So I feel like as time passes on, governments will be more and more uh, regulatory on the emissions. They will be more and more critical on the performance of the machines with BS6 and all the other things that are being that has come in just recently, like in the past few years itself. Should tell you that that's one place that lightweighting can make a huge impact, right? By reducing the weight of your product itself, improving the efficiency of the product, all this will become more sustainable. Using recyclable material, all of this will matter. So I'll give you a few examples of how lightweighting has disrupted real industries, right? So you look at the Boeing 767, a very famous example in lightweighting. They reduce the weight of their overall um, uh, their their aircraft by about 20% overall, which led to 600 liters per hour being saved. Now you calculate that over 200 days of flight time, or 200 days of active uh, duty of that aircraft. You calculate maybe even 6 hours of flight time per day, and that comes into millions of dollars saved per day, per year, right? And that's for just one aircraft. So the impact of such things over an industry can be dramatic. And Boeing has continued this lightweighting aggressively with their future. Even Airbus has done this very aggressively for their aircrafts. One of the things that I was looking, when I was looking for examples, I looked at the best-selling laptops last year. So with a quick Google search, I found that Dell Inspiron was the best-selling laptop globally in 2023. And with a simple Google search, you can also do this. You can look for the best laptops out there, best-selling laptops out there, and then you can look at whether any of them were made out of magnesium alloy. And I found that obviously Dell Inspiron was also made with a magnesium alloy body. So that's uh, uh, something to note, that lightweighting is a critical factor for consumer behavior, right? Recently, we worked with the Chandrayaan 3 as well. We made several components across different categories of their components. So the rover, the lander, different components, just to make the product lightweight, so that it could be efficient as a whole mission, right? So lightweighting is being done everywhere. Three more examples. One, so the first one for electric vehicles. This is something I heard the head of General Motors GM R&D during the Magnesium Association International Magnesium Association conference, where he mentioned a stat. He said that every 10% reduction in overall vehicle weight led to improvement of 8% in IC engine vehicles and 14% in electric vehicles. So you can see how lightweighting is having a significant impact on that industry, and how range anxiety would play into that. Until the battery composition is being disrupted by some other new material apart from lithium ion or any new materials like that, lightweighting is the way that will keep giving them the performance boost. The next two examples are the blue ocean that we saw. So we saw that a lot of like the racket market, which was saturated completely, was reignited by carbon fiber and magnesium alloy rackets. Now it's a $5.18 billion market. And then the last one is about the European bicycle market. This is something, one of the podcasts that we did recently. One of the engineers that we spoke to told us about this, that the foldable lightweight bicycle market in Europe is growing at a rate of 8.92% year on year, which is about 132 million per year. It's growing. It was a simple product, like a bicycle was reinvented with a foldability, and so that they can transit it through metros and through can be carried up the uh, into buildings and into the house itself, was a big disruption. And things like this are possible with lightweighting as the focus. So I hope this kind of helps you understand how lightweighting is important and is making an impact every day on sales of different products and companies. In my experience, I've seen that there's a trend when it comes to lightweighting. So any innovation that is first tried in globally by space tech and defense. We work with space tech and defense for the first 15 years or 12 years of our company, we were working exclusively with space technology and defense. That were the early adopters always. Then it moved down to airborne systems. Once the airborne systems people started taking it up, motorsports starts taking it up, and sports equipment starts taking it up. Once that is covered, we go down to industrial machinery, because that can lead to a direct impact on the profits that can be generated by a business, right? And then eventually it comes down to the mainstream products like automotive and consumer electronics. And this is my insight. I don't know how accurate you would find this, but this is what I have seen. Every time it happens in the same way for me. And once it reaches this mass market product like consumer electronics or automotive, so right now a lot of mobile phones are made out of a magnesium chassis or a body, right? And automotive, there's significantly a large amount of components right now which are made with magnesium. At least globally, in India, with the electric vehicle coming in, and there's no other place apart from magnesium that they can look at. It's coming in a big way in India as well. We are working with a bunch of leaders in the automotive space as well. And once this happens, it trickles down to other industries. It could be biotech, it could be pharma, it could be a bunch of other sectors. So right now we have worked with every sector that I've mentioned on the screen. It is at that point of, at the tipping point where magnesium will become a big deal in the next decade. The last slide about why is, I wanted to share a few insights on the trends that we see. So, and you can see whether this would be relevant for your own product or whether you see any relevance here or not. So whether you believe in this or not, but say we believe that transition to electric and renewable technology will happen. And these would initially be lesser powerful energy systems in comparison to the traditional energy systems that we have. But the consumer will always ask for, the end user will always use for similar or higher performance. And that's where, to meet that delta, you will have to do something significant. And lightweighting would be an important factor in that. The second is obviously low emissions and high efficiency will be demanded, like I covered earlier. So governments will also ask for this, consumer will also ask for this, because there's such a competitive market. You'd want the best out of the products that you're buying, right? The third is complexity in electronics. So as we move forward, I see more and more complex technologies and machines coming up. Everything from IoT, robotics, drones, they're getting more and more complex, and more integration of even industrial equipment. There's more and more electronic infusion into these kind of electromechanical machines. And with that comes a significant increase for lightweighting. It comes a significant increase for EMI, EMC shielding, all of these things, thermal conductivity, all these things kind of play into it. So the next one is, we have already seen this for the past 5 years. We see this continuing and going in a big way as well, where a lot of machines that are only being imported will be reverse engineered and privatized indigenously. We've seen that significantly with a bunch of sectors without naming them, but we've seen that Indian companies are trying to replicate that. And when they try to replicate it, they see a lot of these kind of advanced lightweighting materials being used in those machinery, and then realizing that, okay, this is a significant way that you can lightweight or increase your efficiency of your product, so of your machinery. So we see this happening more and more in India. The last one is obviously handheld and portable technology. Your mobile phone is the evidence for that. You'll see a lot more of that. You'll see everything from binoculars to watches to anything portable, right? You're looking at vacuum cleaners, everything will go more and more mobile, more and more compact. And that's where we feel like lightweighting will make the big difference. So we'll move on to how to lightweight. Removing of material so that you can make the product lightweight or your component lightweight can be obviously done in two ways, right? One is through innovating with design. So you hear topology optimization, lattice structure, honeycomb structure, the a lot in these things. There's a lot of softwares that are specifically coming up for lightweighting, like Altair has launched recently that I was looking at. And recently I also came across a new design philosophy called Tris Innovation. It's a very old philosophy, probably making its entry into India, where they're rethinking how do we think of design, right? And a lot of things can be done to design to help and kind of create that revolutionary design that will impact your product. So that can happen, and I would encourage everyone to do that. But It's time consuming. It's whatever the challenges that you might have. An easy alternative and a substitute, another way of doing achieving the same thing is a substitute material. So switching the traditional material with a new lighter weight material alternative, which meets your mechanical requirements, right? So we are more inclined towards that. We are trying to help companies figure out what kind of lightweight materials can impact their use case and create a drastic difference immediately. When we talk about lightweighting, there are a bunch of materials that are constantly spoken about in India. Obviously, polymers is a big thing that is making a uh, big inroads into India. So glass fiber, carbon fiber, thermoplastics, these are things that are constantly spoken about. Now, if thermal conductivity and high durability, or like having a metal finish is something that would benefit your product, then you would look at metals. And over there, you're looking at high strength steels, you're looking at aluminium alloys, titanium, magnesium, metal matrix composites that are making a entry into India, right? Aluminium always will have a significant percentage of this. Steels will always have a significant percentage of this. But I feel like magnesium will make a big entry into India, even metal matrix composites. So currently, we work with magnesium metal matrix composites based off aluminium and magnesium metal matrix composites, and also aluminium alloys when our customers need it. Magnesium customer needs aluminium, we will do it. So those are the three things that we are into. We made a small chart to help you choose your metal. So I've segregated it into different criterias. So we look at it one by one. So say cost. Aluminium cost cannot be beaten. Obviously, it's the lowest cost per unit volume, but magnesium is a comparable close second, right? So titanium is obviously very costly, but magnesium comes very close to the aluminium price, and that's why it makes it attractive to a lot of design teams that we work with, because there's a lot of things in terms of design alterations that you can do, or even optimizing the product design you can do to bring it almost equivalent to the aluminium price. So it's very appealing as a option. The second is weight. So the lowest density obviously is magnesium. So it is the lightest structural metal on the planet, and it is 33% lighter than aluminium. So it has a significant improvement in terms of weight reduction. Second close is obviously aluminium, and after that is titanium. Titanium is 50% more heavier than magnesium. So uh, in terms of structural properties, titanium is the strongest. Aluminium has the best modulus of elasticity, but magnesium has the best strength to weight ratio. So if you're looking for for your component to have to be lightweight, but also have a high strength to weight strength and durability, magnesium might be a good bet, and that you should look at. In terms of surface finish and coatings, all of them offer uh, great surface finishes and coating variety. That's not a real big challenge. In terms of machinability for your prototyping and for your production related machining, um, aluminium, I'm sure a lot of mechanical designers already would have a lot of experience with. But magnesium is best in terms of machinability, in terms of tool life, in terms of achieving the finish, low cutting forces, energy consumption is low. So it's a easy to machine product. The last factor is thermal and electromagnetic shielding. So aluminium is very good, is the best when it comes to thermal, and good with shielding, right? Magnesium, on the contrary, is a very close second for aluminium, and can come very close to the aluminium thermal conductivity, significantly sufficient for any kind of electronic use case that we've ever seen, right? So thermal conductivity has never been a challenge for magnesium and the use cases that we've worked with. And it has excellent EMI EMC shielding. So wall thickness to shielding ratio is very good with magnesium. You can get good shielding with very thin walls as well. And yeah, so that's a bit about. You can look at this probably once I share the recording of this presentation. You can go through this and kind of decide what makes sense for your product. And I would encourage you to think about your product while you're going through this, so that you can also kind of figure out where you fit in this conversation, and whether it makes sense for you. So we'll go into a deep dive into magnesium. Now, it's kind of funny because I talk to hundreds of design engineers on a monthly basis, and most of them, like a good chunk of them, when I talk to them for the first time, ask me the question, "What is magnesium?" Because they've never been exposed to magnesium. They've heard of aluminium, steel, plastics, but they've never heard of magnesium, right? So I'll start from the basics. Maybe you need it, maybe you don't, but I'll cover it right from the beginning. So this is not a science test, but magnesium is obviously a very light metal on the elements table, and it's a metal essentially, right? So it's the eighth most abundant element on the Earth's crust. It is rarely found in its pure form. It is found from seawater or through minerals and is extracted from there. So it extraction happens in across the world, majorly in China. I'll cover that as well. Is the third most commonly used structural metal globally. In India, there's been a slow entry or a very small entry for magnesium because of the lack of knowledge about magnesium. There's no experts, there's no companies, and there are not a lot of companies who do magnesium. There's not a lot of experts of magnesium in India. So we've been like in this industry for 29 years, and every company that has started has already shut down, or very few handful that are still attempting magnesium right now. We being the oldest, right? So there's not been a lot of education of magnesium. It's 100% recyclable as well. So like I was saying, green materials, this would come in terms of supply chain. 90% of all magnesium is extracted in China in mines, and from that 85% comes from a single district. So which is a northern Mongolia kind of region, Shaanxi province. That's where majority of the magnesium is extracted globally. If you're an aerospace or a defense company and you have a problem with China, then you can also look at raw material that comes from Germany, UK, Israel, which most of it is also extracted from seawater over there. So it also has its own purity benefits. So that's one more factor. Irrespective, there's always a abundance of supply of pure magnesium in India, because magnesium is not just used by the magnesium alloy industry for making components, but majority of magnesium that comes into India is used for desulfurization of steel. It is used for aluminium alloying. So there's always abundance of magnesium that is available in local markets itself. Though there is no abundant reserve of magnesium in India, there's no active mines. There are reserves, but there are no mines in India. There used to be one about I think 15 years ago, but they shut down due to dumping, Chinese dumping long back. Now we have a couple of more people coming in attempting extraction in India. You want to get into magnesium alloys and you want to understand what the alloy grades are. So I'll take you through three of the major series that comes into conversations for any product. First one, and the most commonly used commercial alloy, is the AZ series. So it's nothing complicated. As you can see, A from the table on the right is aluminium and Z is zinc, right? So AZ, and then 9 and 1 are corresponds to the aluminium content, which is 9%, zinc 1%. So that's the composition, and the remaining is all magnesium. So that's about 90% magnesium, 9% aluminium, 1% zinc. This is the most commonly used alloy. Almost every industry, when they start off with magnesium, start with AZ series, and it is can be used for any manufacturing process, whether it be casting, forging, extrusion, whatever it might be. There's a variant of AZ series which can be used. So and all the properties of these would be comparable with every aluminium alloy series, which is LM series, LM4, LM6, LM25, all these ADC12. You'll find an equivalent of that, or 6061, 7075. You'll find an equivalent of that in magnesium also. So in terms of mechanical properties, that should not be a concern at all. The second major alloy series that we work with, and you see use cases for in India, is the aluminium manganese series. M is for manganese. So aluminium is 6% or 5%, then manganese is less than 1%. This is the second alloy series, which is the AM series. Now this has very high elongation and damping coefficient. So it is usually used in impact critical components. For example, all steering wheels in India are made out of this metal, this alloy, because it's a safety feature. When there's a crash, the driver falls onto the steering wheel. You don't want the steering wheel to crush the ribs of the driver, but absorb the shock. How you think about damping is you take a hammer and you start hammering a tree trunk. You'll observe that majority of the shock is absorbed by the tree trunk and is not reflected back to the hammer. So that's exactly how magnesium is. Magnesium has very high damping. It will absorb the shock and not react back. So it's kind of like shock absorption capability. So AM series has very good shock absorption. We are now making cricket helmets out of this. We're now making a lot of car cross beams are being made out of this. A lot of crash critical components or impact critical components are being made out of this. That's the second major alloy series that is in play in India. And the third series is the rare earth series. This is a more expensive alloy, which is since you're using rare earth, and this is nothing complicated. This is just one of them. Zinc, and E stands for rare earth. So that's 4% zinc and 1% rare earth. And what these kind of rare earth alloys do is that they are use cases for elevated temperature use cases, right? So where the working temperatures are around 250 degrees, 350 degrees, and you still want the alloy to maintain strength and not lose strength through creep. That's where these rare earth series are applied. So we've seen people use these kind of alloys for automotive engine parts. We've seen them used for helicopter gearboxes, to fighter jets, different kind of use cases. Airborne systems use this very regularly. Even defense systems use this very regularly. So that is the third kind of major series. Now, one thing you should understand is that there's a range of these, apart from the ones mentioned here, which is just the ones that I could mention, but there's a lot more than what I mentioned here. So with just a change in the composition, magnesium starts giving a completely new property. For example, if you want very high thermal conductivity, something that is very close to aluminium, you would use something like a ZM series. So zinc and manganese, and that would bring thermal conductivity to as high as 125 to one. I think aluminium has something around 150. This would come to 125, which is significantly high for any kind of electronics or any kind of mechanical use case in general, or even for heat sinks. This is more than sufficient. So you'll achieve lightweighting and you'll also get thermal conductivity. So any kind of property that you want, if you tell our team the property that you want to enhance in magnesium, we can do that for you. You want to make magnesium absolutely corrosive in biomedical use case, we can make that happen. If you want it to be as good as stainless steel, we can make that happen, right? So it's very versatile as a metal. So we'll go through the advantages. Every customer that ever comes to us, their primary property that they're looking at is always lightweighting, but there's always a secondary benefit that they're looking at. So some of the other benefits that I mentioned is high shock and vibration damping, right? So you're trying to reduce the damage to internal electronics in a consumer electronic product like a laptop, a rugged laptop, a rugged tablet, or a mobile phone, right? These kind of products, or even a drone. They crash. You don't want the internal electronics to get very badly affected. You want high damping. Even for audio components where you want to absorb unnecessary vibrations, or in industrial equipment where you want to reduce the amount of vibrations to improve wear and tear, right? So those kind of things, high damping is another factor. It has obviously the best strength to weight ratio. It has excellent EMI EMC shielding. A unique property that I mentioned earlier is corrosive and non-corrosive on demand depending on the chemical composition. So corrosive in biomedical and oil industry for fracking and products like that. You want it to be highly corrosive, and you also want it to be absolutely non-corrosive for any kind of consumer-related product. So both can be achieved through magnesium, and it also has high electrical and thermal conductivity, like we spoke about. So converting that into understandable way, obviously a lot of our customers are trying to reduce the weight of their metal parts by 33%. That's something that is easily achievable. Reduce vibration and noise, and reduce wear and tear. They're trying to lower the effort to overcome rotational inertia. Now, this would be in textile machinery, tire building machines, wheel rims, these kind of things, right? And the next one is to improve mobility and runtime. This is for products like robotics, drones, or even electric vehicles, right? They're trying to increase the performance of their product. The fifth is to reduce human effort. So if you're making sports equipment, you want the player to wear this safety equipment, but not find it very heavy, right? You want it to be ergonomic, you want it to be comfortable for long-term use, or even something like hand drills that are made for power tools, right? If it's a handheld power tool, you want the worker in a work setting to be able to use it for the longest period without fatiguing or impacting uh, uh, impacting their strength bearing, whatever, right? They're trying to make the person use it for a longer period of time, and that can be done through magnesium. And the last one I already mentioned, how drop, dent, and crash and impact can be prevented. So rugged laptops are a major use case for magnesium for that reason. So this is kind of, if I don't know how many of you are interested in emissions and all of that, but as you can see from this chart, this is from the International Lightweighting Journal, a table that we found. So they use steel as the baseline, and they were comparing other lightweighting materials, and they found that with magnesium you get the maximum amount of weight saving in comparison to steel. And it's slightly more expensive, but it also talks about how is it impacting your product, right? That's one other factor. And the in terms of emission reduction also, it's significantly the highest is possible through magnesium. So this I kind of covered, but let's say that places where aluminium is the biggest competitor to magnesium in India. So if you look at places where aluminium is better, it's obviously thermal conductivity and cost. That's where that is number one. Whereas magnesium is best in damping coefficient, density, least amount of draft, ability to cast thin walls. So we can cast walls as thin as 0.6 mm without a sweat. Like we can do 0.8 mm natural, like easily in die casting. So you can machine magnesium to very thin wall thicknesses. Also, that's an additional weight saving that you can do beyond what aluminium designs can achieve. So shielding, machinability, recyclability, die life. I'll cover this a little later. So a lot of benefits in that sense. So I'll take you through the three major benefits. Lightweighting, like we already spoke. These are a few examples that you have. So it's 33% lighter than aluminium, 75% lighter than steel, and 50% lighter than titanium. So even the strength difference with steel and titanium that magnesium has can be compensated with a slight increase in thickness of the wall, right? So like I was mentioning, the cricket helmet, we had to increase the wall thickness, the diameter of the grill from 2 mm to 3 mm, and that was sufficient to maintain the strength, right? So it is not a significant, and with that increase in thickness also, you can achieve a significant weight saving. So in that case, in the cricket helmet case, we saved about 50% lighter than what it was possible for steel, even after the thickness increase. So you have a few examples here of the Boeing 767 saved about 37,000 liters per year for every kg of magnesium you replace with aluminium component. This is an old slide that I made long back, but you can Google this yourself. You can look at the top selling laptops, look at how many of them are made with the magnesium body or the magnesium chassis. It's a critical factor that is being used by this industry. So in terms of mileage, you are getting anywhere, but just by replacing an aluminium wheel rim with a magnesium wheel rim, you'll get a 5 to 7% increase in mileage, right? And you get a 4% improvement in braking and acceleration. You'll get longer life of suspensions and brake components. So that's one. The second major one is damping. So depending on the alloy of magnesium, you get anywhere between 30 to 100 times better damping coefficient than aluminium. And that is the reason why it is used. Vibration testing equipment itself is made out of magnesium, right? A lot of components that we make it regularly for vibration testing industry. Every Indian vibration testing industry makes it out of magnesium, and internationally as well. Uh, in the laptop industry, obviously Protecting internal electronics is critical. So there also you see a lot of use cases. And the steering wheel example I already shared, how it's a safety related component with damping as the priority. The third is EMI AMC shielding. So it has the best wall thickness to shielding ratio. So in terms of its use extensively in medical devices, because there's a very high standard for that in that industry for shielding. It's also used very frequently in drones and any kind of defense and aerospace products, because shielding is also very important in those sectors. Now, this is the important section. There's a lot of myths that we come across when people, when we ask them, why are you not using magnesium? One of these would definitely come into play. So the 4 reasons people will tell me about is it's too expensive, it corrodes easily, it burns too easily, or is a fire hazard, and creep resistance at elevated temperature. The creep resistance at elevated temperature, I told you about the rare earth series. A lot of them are not aware that there is a series of magnesium specifically catering to creep resistance. So I won't cover that. I'll cover the top 3, right? So too expensive. So first part about costing, you would see that this is an old slide. The price of magnesium is about 240 rupees per kg right now, which is almost equivalent to aluminium. This is also an old slide. Aluminium must be around 240, 230 range as well right now. If you see the die casting rates, there's a huge overlap in the cost. So depending on your component, it would cost you anywhere between 450 to 700 rupees per kg. Whereas when you're looking at aluminium, it will be about 350 to 550. Zinc is, I just mentioned it because of the die casting, but you can look at aluminium and magnesium specifically. So there's a huge overlap. That is one point. The second is that you have to remember, because of the lower density, if 1 kg of magnesium is giving you 3 components, aluminium can only give you 2 components, and even lesser in zinc, right? So there's saving in that in terms of raw material as well, the amount of raw material used. The third factor when it comes to cost is the die cost. So when you look at something like die casting, an average aluminium die would give you somewhere around 1 lakh shots. Whereas because of the low affinity of magnesium to steel, you'll get about double of that at a minimum when you're working with magnesium. So if say the die was costing you about 10 lakh, you're directly saving 10 lakh rupees just in the die, because you can run the die for much longer. And if it's a serial production component where you're getting 4 lakh units, you can get up to as high as 4 lakh units as well in a single die if it's continuously running, right? So there's a lot of saving there as well, which will accumulate. All of this will accumulate over a period of time. So it will end up becoming cheaper almost in comparison to aluminium if you consider these costings. The third is you can also reduce weight due to the ability to cast thin walls or to maintain stiffness at thin wall thickness. So this is stiffness at equal weight. So magnesium, as I mentioned, there are some components where you don't, some features of your component that don't require uh, load bearing strength. They just require stiffness. So in those sections, we encourage our customers to reduce the wall thickness there, because magnesium can be cast in thin walls. So you can reduce if it was about 2 mm, you can reduce it to 1 mm. That is possible with magnesium, right? And additionally, you can also go on, uh, so you can maintain, and it will reduce the weight as well of the component, which will help you save some metal and also save some cost. So these are the 4 things I wanted to cover in terms of costing. The second myth, which is about corrosion. Now, if you look at uh, now, there's a big magnesium work was corrosive if you spoke maybe about 20, 30 years ago. Now, with the latest revisions of alloys that have come in, it has become almost very similar to aluminium, right? Aluminium anti-corrosion properties are similar in magnesium with AZ91E, which has come in. Here you can see the revision of the alloy, which is AZ91. D stands for the revision of the alloy. So it's CDE. We are at revision number E, which has become, every year the industry refines it further to make it less corrosive. So this itself has significantly improved the standard for corrosion. But additionally, if you're taking a component from me, I will give it to you with coating. And coatings in magnesium are so good. Some of them are guaranteeing 99 years anti-corrosion guarantees, right? So there's a company called Indestructible Paints that offers something like that. So it's for aerospace and defense use case, but there are very good service life corrosion resistance proper like options available. So if it's a marine environment, we have something. If it's a highly corrosive environment, also we have something. So that should not be a concern. One thing you should probably consider is the galvanic corrosion. You have to design for that, right? The biggest one of them all, and I'm sure some of you also had this, is that you feel like magnesium catches fire. So there are two things. This is also true. Magnesium is very dangerous in powder form, so it catches fire very easily, and it's very difficult to put out magnesium powder fires. So that is true. That's why it's used in cracker industry for sparklers, and different kind of crackers use magnesium powders. The second is for molten state. So molten state, when it comes with contact with moisture, it has the capability to explode. So that's why you don't see a lot of companies in India working with magnesium. That's something that we were trained 20 plus years ago by a global player on magnesium safety. That's the reason why we still survive. We are able to do defense and aerospace quality business. And that's one of those reasons. Molten magnesium is very dangerous, and that's why you don't see a lot of companies starting to do that. So you cannot treat it like aluminium, you just melt it and pour it. That's not how magnesium can be done. So that is one thing. But in finished format, so you have day-to-day components that you come across daily, from in aircrafts to wheel rims in cars to your steering wheel of your own car is probably made out of magnesium, right? And you don't see them catch fire. Even with a wheel rim, if it drags along the road and there's a lot of abrasion, still it will not catch fire, because magnesium alloys in general, in their component form, is flame retardant. So this is not true at all, and this is probably the biggest barrier misconception a lot of people have. uh, when it comes to powder form, obviously when you're doing machining, CNC machining with fine cuts, you might be producing some powder, but with basic hygiene of clearing out the scrap and segregating all of that and storing it safely, you should not have that challenge. We work with multiple of our customers do their own machining. We have our own machining centers. If you are interested, you can always come and see our machining centers as well. So that's something. The only probably factor you should consider for your product specifically is, do you see a trend of tampering? So, for example, in the UK, uh, every like there's a lot of modification business that happens in the UK with car engines. So they were when Volkswagen was making their engines out of magnesium, there used to be a lot of trend of these local mechanics trying to weld things into magnesium, not knowing that it's magnesium. So they would try to weld in aluminium or something else, and that would catch fire. So those kind of cultural and trend kind of things has to be evaluated by yourself, whether this is something that you see playing into your industry and product, and then you can decide. We'll move on to the manufacturing possibilities. I'll cover a bit about what is possible, what is not possible with magnesium. So the first thing that you see in terms of raw material itself, a lot of our customers want to do their own prototyping, want to do their own production. So they take cast blocks, roll plates, forged blocks, billets from us, and we provide that to them, and they can do their they do their production themselves. So I'm sure that if some of you want to try it, you'll want to do your own prototyping, or if you have your machine CNC machining centers. So we can also do it, but if you want to do it yourself, we can give you raw material to get started. The second thing, sorry, the next thing is obviously all the available magnesium processes. So we have all kinds of casting capability. So high pressure die casting, sand casting, gravity casting, centrifugal casting, machine components, extrusions, forgings, roll plates, sheet bending. If there's a process currently that is not available with us, but you want the component to be made out of that process, we will develop it for you. We are committed to being the one-stop solution to all magnesium component solutions for India. So last year itself, we developed cold drawing a couple of years ago actually, and then this year we will be developing closed closed die forging. So that will play into wheel rim business in India. So I'll take you through each one of these. So in terms of extrusions, It's done the same way as aluminium is extruded through a tungsten carbide die, but the process is slightly different, right? Temperatures are different. The stress and strain is different. So we make rods for Swiss type lathe kind of components, and also we do a lot of profiles. So here you can see few examples. So solar water heater anodes, or it could be spoke wheel rims. So it's extruded and then bent, rolled. So this was for the electric motorcycle market. And then the Bofors shell, it was actually extruded as a pipe and then machined later. So these are just few examples of us extruded products. Uh, Second, the biggest category for magnesium is obviously in aerospace and defense is for in sand castings. This is just a few pictures. We have a total melt of about 5 tons at a single time that we can melt. We are very proud of our capability in terms of sand casting. We can do highly complex castings, as you can see the gearbox over here. This is completely hollow on the inside, and there's a 2 mm piping going from within the wall of the wall of the casting itself. So we've done a lot of components like this, which are extremely complex, and we've been successful. So in terms of sand casting, we think we are one of the we would consider ourselves one of the best in the world in terms of magnesium sand casting at least. And no size is a limit for us. We've done for the 1.7 ton casting, we did an actual melt of 2.7 tons. And any kind of complex design with cores, metal cores or sand cores, we can do it all. Gravity die casting, so it's the same. We use MSN cast iron gravity dies with the appropriate shrinkage allowances. This is recently we did a racing wheel rim for the international market. Uh, this is like as you can see, it's a great finish right out of the die. This is right out of the die. And these are some other components that we've done through GDC. So Akash Missile is our continuous order for the electronic enclosure of the Akash missile. High pressure die casting, if you're not aware, it's a process. We have capability from 60 tonnage to 1200 tonnage. Any size component within that range, we can support you. The end product is obviously has a great net finish. Holes and critical tolerances obviously have to be done later, and the tolerances will be within 0.1 to 0.2 mm tolerance. Just a few examples of our die casted products. We've done everything from optoelectronics, battery housings, consumer electronics, mobile phones. So automotive, defense, aerospace, die castings for all of these. So that's a big chunk of our revenue will always come from die casting. The last part is about design capability. So if you're not already in magnesium, we can obviously help you redesign your component in magnesium. If you're currently using steel, aluminum, or plastics, we can help you transition to this. If you are using aluminum, then there's not a lot of design change because the properties are very similar. You can almost use the same die. You can use the same die for magnesium. The next part is about weight optimization. So uh, if you have a component that you want to lightweight, you can send it to us and we can help you with the weight optimization of that component. The third is very basic designs like battery enclosures and simple products we can design in-house as well. So we have that capability, and any kind of analysis, FE analysis we can do, we have that capability. So these are the 4 ways that we can support in terms of design. Currently, in terms of our ongoing R&D, we are working on a very it's a rare technology called gravity rheocasting. There also I mentioned closed die forgings we are working on. We are working on a dissolvable fracking tool. We're also working on multiple types of new kinds of coatings for magnesium. We're constantly in R&D, uh, figuring out how to expand the use case for magnesium in India. So yeah, that was the presentation. Thank you. Now we can move on to the questions. If we can have questions, I'll just check the chat box. And so one of the questions that I see is that why is the rate of magnesium castings more? So one of the reasons is the process cost. So currently, since there's not like a vibrant environment of magnesium castings in India, there's a hardly less than 2 or 3 companies that even know how to do magnesium castings in India. So there's not like a huge industry for the additives of magnesium. So all the additives of which are used to purify the alloy and to improve castability and to reduce fire hazard in molten state. All these are not available in India by local vendors. So all of this is imported from European companies, which increases significantly the cost. As the market increases, we have more and more, a few additive companies that have come in India, limited, but there's definitely uh, increase of that in that is one of the factors why it's more expensive. The additives are very expensive right now, but as extraction will start in India, and also the more additive companies that come into India which can do magnesium, the cost of magnesium will significantly drop and probably lower than aluminium. So that is bound to happen in the next decade for sure. Shrinkage is slightly different. So one of the questions is shrinkage the same as aluminium? It's slightly different. It's not too much of a difference. I understand that you're probably considering like a die that was made out of for aluminium. Can you use it for kind of magnesium? Yes, you can, with slight edits to the flow rate. Essentially, that is one. Yeah, but shrinkage is almost the same. It's not very different. I'll look at some of the other questions that were sent to us. Someone asked what material is used for automotive product. So like I mentioned, the AM series is the one that is used for automotive majorly, and also AZ91, AZ series. Aluminium zinc series, aluminium manganese series. Those two are used extensively. Can additive manufacturing be used for this purpose? Magnesium prototyping currently cannot be done through additive manufacturing. There are two companies globally which have proven additive manufacturing for magnesium, but they're not to the level that we can commercialize it with a with a serious buyer. So it is still under the works. We are also trying it with a bunch of 3D printing vendors in India. That's also part of our R&D, but we're taking it slow because we don't see a lot of use case for a very big use case for additive manufacturing for magnesium yet. So that's, we cannot currently use additive manufacturing for magnesium. What I can do, actually, one of the things that we can do apart from this is that someone was asking me, can you share the list of grades of aluminium? So along with the recording of this webinar, we will also be sharing the data sheet with all the alloys. We'll also be sharing a couple of ebooks. We've made ebooks on lightweighting of magnesium, lightweighting of your mechanical design, different ways that we see that are trending for the future. We wrote an ebook on about that, and also we are writing an ebook on magnesium alloys. So both of those we will share along with the presentation, with the recording of this webinar. So that we will share. How can we use these materials in electric vehicle manufacturing? So there's a lot of use case for converting battery enclosures to wheel rims to electronic enclosures, or say the display systems. All of these are easy bets to make when it comes to electric vehicle specifically. Extensively used. All this is already done in the US. So in US and in Europe, magnesium is extensively used in electric vehicles. So you can look at the same kind of use cases in electric vehicles. Probably also in cars, you can look at door systems. There's a lot of other things also. So if I can share a presentation with a single slide about all the history of magnesium use cases over the years, what all has been developed already. So car cross beams, steering wheels, then oil sumps, steering columns, all of these are already made in magnesium internationally. So I can share a single slide which shows a history of when it was developed for what product. I have a slide for that. I can probably share it with the presentation.
I think we've got a couple of questions in the chat, Anisha.
1 second. Yes. So one of the questions is, can we make piecewise items? Yes. So a single component also we can make. So every customer that we have starts with a single component, single prototype. So if you have a single component that you want to start with, it could be like a fastener as well, or it could be a small component. You want a prototype, we can help you with that. So every customer of ours starts with a single prototype, then scales up as it proves into their machine. So once performance is proven, then automatically it'll make sense for you to scale. So you were mentioning tire building industry, we work with it extensively, and we can help you with that. We make a lot of components for tire building, single components, not in that sense. So we do only TIG welding. So when someone was asking about welding, we do TIG welding in house for weld structures, and that's the only one we are currently doing. I am working. We have supported a lot of researchers who are working with friction welding as well. So there is research already happening related to friction welding. I'm sure their research is published as well. But if there's a specific use case where friction welding only is required, then I don't see that being too much of a challenge. Please continue with the questions, everyone. Someone was asking about plating of magnesium. We currently are not doing any plating related to magnesium. All right. So, like I mentioned, I don't know whether there's Mr. Nagarajan. You can ask the question in the chat box. Okay. So, if you have any other questions, please keep mentioning it in the chat box, and I'll be here for as long as it takes. If at the end of this, it'll take us a couple of a week or so, but we'll edit this recording. We'll make a list of all the questions that was asked. The questions, there's some questions that I don't know the answer to, so I've not mentioned it. So I will get those answered by my team, and also send you a list of the FAQ, the questions that was asked by email or during the registration, and we can send you a list of that along with the webinar recording and the ebooks that we have, so that we can do. If you're keen on trying out magnesium for your use case, and you're looking for support from our side, you can schedule a call with us. You can do that on our website. You can log into the contact page and leave a message that you want to book a session with your phone number and email ID. My team will reach out to you, book a session, and if after understanding your use case, we would be more than happy to send you test bars or any kind of testing requirements that you might have to prove that product within internally for your product. So if you need any kind of plates for testing or any kind of test bars, we'll send that to you. Right. If you no longer have any questions, you feel free to drop out. I'm sharing a slide with our contact details, so you can take a note and email me directly if needed. If you don't want to ask a question directly over here, you can send us a question on that. If you have a question, please mention it in the chat box and I'll answer it. If you don't no longer have any questions, you can, this is the end of the presentation. You can drop out if you feel. The call will be active till 5:30. So we'll be ending the call now. No longer any questions. So Ritvik, can you take a note of all the questions that was asked during the presentation?
Yeah, I've taken a note of them.
And the names also of the people who asked?
Yeah, okay.